Welcome back. We've been learning about linked lists, and in the last lesson we created a dummy linked list in Python so we could learn a little bit about how list operations work. We're going to continue with this Python programming in the current lesson. This lesson is mostly a series of challenges from me to you. We're going to see how to append a new item to a list, and then I'm going to challenge you to write more code to do various other useful activities with a linked list. For example, search, edit, delete and insert values into the list. This is quite a difficult set of activities, so do as much as you want to do. If you're good at programming, this will give you a chance to practice your programming skills. In the last lesson, I created a dummy linked list. If you're my students, I gave you this code to work with. Otherwise, you could just type it for yourself. And this is a dummy linked list made of a list of nodes. Each node contains two items, the data value and a pointer to the next node. We wrote commands last time to traverse the list and print out all the values in the list. Today we're going to add new code to append a new node to the end of the list. And the way we will do it is in 3 steps. We will make a new node at the free data location. We will link it to the end of the list, and then finally let's traverse the list to see that we've successfully added the new value to the end. So first of all, we're going to make a new node. We've got to get the data, I suppose, input by the user. We've got to make a new node that stores that data at the free location. So you can pause the video and write those lines at the bottom of our linked list program. Get some data, create a new node at the free pointer. So let's do that. Here's the code. So I've input some data and I've stored it as new data, and I've created a new node with the new data and obviously no pointer, the pointer is empty. And then I've added the new node to my list at the free pointer. Now I'm going to traverse to the end of the list and change the final pointer in my list so it points to this new node that I have added. And remember, at the very end I have to update the free node pointer because I need to point to a new empty data location. So this is a bit of extra work, and I'm going to show you the answer to it in a minute. You can try it without looking at my answer, or you can copy my code. Here it comes. So we start at the header of the list and we traverse the entire list. I've taken out the command that prints out the values as we go. So we're just going through the list to get to the end. At the end, I'm changing my final node pointer to point to the free node. That's where my new data is. And then I'm finally updating the free node to point to another empty location. However, of course, if my list is full, so all the data locations are in use, I can't append. So for an extra challenge, add some extra code to check if my list is full. And in that case, I would show a message to my user saying the list is full. No more data can be added. All right, so we're really off now into optional territory. There are a lot of other things we can do with a linked list. We can search for data, we can edit data, we can delete and insert data. And I'm really going to leave this up to you to explore for yourself. And the remainder of this lesson has some optional things for you to try. I suggest that you write a menu in the main program so the user can choose what they want to do, such as append, insert, delete, edit, and so on. And then write a function to carry out each of the operations and link that from the main program. For example, here's a challenge. Get the user to enter a search term, traverse the list using the commands that we've already learned, and return a yes/no value. Is the search term anywhere in the list? We could do this using the linear search. We could adapt our code, which we've already written, to traverse the list. And instead of printing each data item, we would check whether it matches the search term. And we could have a Boolean variable for found, which goes to true, starts at false and changes to true if we find a match to the search term. So see if you can write that code without any help from me. If we wanted to edit data, for instance, we could use that search function that I've just described to search for the data we want to edit. Enter a new value and overwrite the previous data value of that node. Again, I'm not going to show you this code. This is just something for you to try. If we want to insert a node into our linked list, we would make the new node, use the search command to search for the place where we want to insert it, copy that pointer into our new node and overwrite the previous pointer so that our new node is inserted halfway through the list. And finally, we could delete a node. Once again, use our search program, search function, which we've just developed, to find the item in the list, copy its pointer and overwrite the previous pointer so that the computer will skip over the node that we want to delete. So I'm setting you a lot of challenges here and I'm not giving you much help, but this gives you plenty of opportunity to practice and explore your Python skills. To recap, in this lesson, I have spoken about how to append, search, edit, insert, and delete nodes from a linked list. I haven't given you the code for most of this, so it really is a programming challenge for you. And I'm leaving you with that as a set of ideas for developing your Python programming skills. In the next lesson, I'll talk very briefly about how we might do the same thing using object-oriented programming.